afternoon. It's my honor as a member of the advisory board and as a peer reviewer to introduce our next two speakers. As a new member of Microsoft, I got exposure to this presentation about 4 weeks into my newfound job, and I was blown away. So this was my #1 pick in terms of the peer mentorship, and I'm really happy to be presenting this with you. So please welcome Joe Vogt and Phil Cousins.
Hey everyone, how's it going? So I'm Phil, and this is Joe, and today we're here to talk to you about our journey of developing Gears of War at scale. This talk covers infrastructure, will be very applicable to both people in IT and engineering, but also hopefully will be valuable for anyone who's like an art manager in production to help understand the challenges and some solutions for ensuring your integrated development can scale across the globe and remain efficient at remote locations, as well as your internal central studio. So here's our agenda. We're going to give you a brief intro of what we do and who we are, and then we're going to jump back in about 5 years to discuss some of the challenges we initially faced when we started looking at developing games at scale and some of our philosophies around how we wanted to work and why. From there, we're going to go on a journey from our humble beginnings all the way through to about the present day. Then after that, we're going to spend a little time looking into the future and what it might hold for us over the next 2 to 3 years. Then we're going to wrap it up by reiterating some of the key points that we've made during the presentation, and we'll leave some time at the end for some questions. So some intros. So I'm Phil. I'm the lead of our tools, builds, and automation group at the Coalition.
Hi, I'm Joe Vogt. I lead the IT services team. We provide the studio with infrastructure and systems support.
Awesome. So obviously, me and Joe. So we work at the Coalition. The Coalition is a first-party game studio located here in Vancouver, BC. If you actually look out the window over there, you'll see a Microsoft sign. That's actually our building, so we can give our guys a wave. So we make AAA games for Xbox and Windows 10. Our studio has grown to about 350 staff on site. So we made up of the usual of software engineers, designers, artists, production, quality assurance, etc. But we also work with around a dozen different development partners from around the world who help to contribute on an average of about 25,000 commits a day into our Perforce server and about 250 gigs of content which goes in from us and our external partners. Since early 2014, we've been owners of the Gears of War franchise, and our first title as a studio was the remastered version of Gears of War 1, which we called Gears of War Ultimate Edition, which was released in 2015. Our second title was Gears of War 4, which we released in 2016, and today we're working hard at producing Gears 5, and we have a little sampling today on a video of what we're currently working on.
Something's happening to me. For months now, I've been having these dreams. Nightmares. But I think they were messages.
It's your grandmother's? There's a place up north. I think we can find you answers there.
Where are we going?
Back to where it all began. I need to know the truth.
Or are we the prey?
She'd never be our enemy by choice. I know that. But what if it's not her choice? The necklace? That's a locust symbol.
I want it out of my head. I want it to stop.
Katie.
Mom!
Cut me loose. Please.
So next we're going to take a look at some of the challenges that we faced over our journey, as well as some ideas and philosophies about how we've, these have guided us along our path. And Joe's going to tell you more about this.
Great. Thanks, Phil. So I want to start today by looking at a few of the challenges we faced when we were looking at how to approach scaling our studio to build Gears. We all know making video games is a huge undertaking, especially big AAA games. It's big teams, big budgets, and even bigger expectations. As a first-party studio, we want to build games that showcase the advanced capabilities and the features of our platform. And we want to build games that push the limits of visual fidelity, gameplay performance, and product quality. But we can't do it alone. We need to enlist the help of hundreds of talented artists and engineers with a wide variety of skill sets in different capacities at different times throughout a years-long production schedule. And in fact, our actual project staffing over the last 5 years reflects this. There's been a dramatic increase in the number of external staff working on our projects. When you look at when we started, around 2013, external staff made up around a quarter of our overall team size. Compare that with today, we have almost twice as many external staff as internal. So we had some unique development challenges when we started this process. When we started with Gears in 2014, the team at the Coalition was still relatively new. The core team had been working together for a year or two, but had never actually shipped a product as a studio. Despite this, the team had been built from the ground up with veteran developers from top studios, so we had a lot of experience to draw from. It was a new franchise. Well, of course, Gears of War isn't new, but it was new to us, and it was new to Microsoft. We felt incredibly fortunate to have been given the opportunity to take on Gears of War, but there was a great responsibility to do it right. The bar had been set very high. We also took on a new engine. By 2014, the studio had started working in Unreal 4 engine, but it continued to be in a state of heavy development throughout the production of our games, even up until the point where we shipped Gears of War 4 in 2016. So despite these challenges, as a studio, we were very excited to be building Gears of War. I mean, are you kidding me? It's a Gears of War game, you know? There was a real energy and excitement about making a Gears game, and I think it shows in our motivation and our drive to build the best product that we can. So early on, as we looked at how we wanted to work with external development partners, it became clear that an integrated development approach would need to be our goal. So let's look at some of the philosophies that drove this. We knew that we needed to scale externally, but we wanted to scale externally without it feeling like it was external. We wanted it to feel more seamless without the traditional barriers. We wanted working with external teams to not feel too different than working with internal teams. We wanted to share the same tools and workflows. We wanted to have one set of guidelines and policies that everyone could follow, internal and external. We also wanted to avoid the traditional over-the-fence integration approach of needing a small army of internal staff dedicated to importing content into the game every day. We also wanted to be able to outsource anything, from engineering features to cinematics to character animations to static meshes. Any element should be a candidate for external development. We also wanted to leverage our industry-leading Unreal Editor workflows, which would allow our partners to take on more complex and more deeply integrated tasks. And lastly, ownership and responsibility. We wanted our partners to work directly in the engine so they could see the results themselves directly in the game. This provides immediate contextual feedback and creates a sense of end-to-end ownership over what they are creating in a way that we believe impacts the game in a positive way. To do this, we needed our partners to be able to work the way we work, using the same tools, working in the same environment, seeing the same things we were seeing day to day. So how did we get there? Let's look at this as a bit of a journey, kind of an adventure. When we started our journey, much like many other adventures, we understood kind of where we wanted to go, but we really didn't know how we were going to get there. So join me as we look at how we took our first steps into our external development journey and what we learned along the way. So we started with the foundation of what would ultimately become our full external development stack. The first layer is the key foundation on which our integrated development story is built, source control. In our case, we use Perforce. All of our code, assets, and tools are stored in a large on-premises Perforce server located here in Vancouver, just across the street, actually. So Perforce is our core. In order to perform any sort of development work on Gears, you are going to need access to Perforce, one way or the other. So this presents us with our first challenge, how to deliver our code and tools to our partners. All the data and tools we needed to share with our partners is located here in Vancouver, BC, but our partners are located around the world. To make it more difficult, Gears is pretty big. Sometimes our partners will need to sync hundreds of gigabytes per day just to keep up with our changes. It was critical that we provide reliable, high-performance access to our source control system, especially critical if we expected our partners to work in an integrated development model. Fortunately, the Perforce platform supports this type of global development scenario through the use of Perforce proxies and brokers. Perforce proxy servers are content caches that sit at partner sites and provide users with fast access to a local copy of the data. These proxy servers connect back to our Perforce server here in Vancouver through broker servers that live on our network edge and act as secure access gateways for the Perforce traffic. We deployed 3 brokers in different Microsoft data centers located in strategic locations around the world to provide better connectivity options. 1 broker in central US, 1 in Northern Europe, and 1 in Southeast Asia. Proxy servers at partner sites connect to the broker closest to them. This minimizes latency and maximizes performance. Let's take a closer look at how the Perforce components work together at a typical partner site. The proxy works pretty much like any other caching proxy solution. Users at the partner site use Perforce client to connect to a local proxy server and request to sync data from our depot. The depot reaches back out across the internet to a Perforce broker sitting in a nearby Microsoft data center. This broker provides secure connectivity back across the Microsoft internal network all the way to our Perforce server located here in Vancouver. The Perforce server in Vancouver sends the requested data back out to the remote proxy where it's delivered to the user. That proxy then stores that data in its cache, and so that next time a user asks for it, it's already downloaded and ready to go. Back to our journey. Our first steps in our external development journey were foundational. Building the global network connectivity and getting our partners up and running with Perforce proxy servers. Our partners now had robust and reliable access to our data. For the next step in our journey, we wanted to start distributing our tools and workflows to our partners. So now Phil is going to tell you a bit more about how we did that.
So building on top of what we've already set up here, it made sense to deploy our tools and workflows to our partners using Perforce. It was already in place and it was working. So this would all just work great, right? You know, the partners had Perforce, they could just sync up and everything would just work. Well, obviously it wasn't that easy for us. So this is a very scary diagram. I'm sure we all have videos like this somewhere, so I thought I'd pull out ours just to set the tone. So like most people here today, we have a lot of different tools and workflows, and my team works very hard developing complex web of interactions to basically make the development team's life way easier. However, when we first started on this journey, we didn't fully appreciate how complicated it would be to start onboarding some of our first partners, given this complexity. So to give some context to this conversation, I want to introduce you to a little tool that we have at home called Hammer. Hammer is the tool that we designed and wrote to be the first and the last tool that anyone in our studio would have to know how to use. Well, obviously not quite the last. Think of it as a one-stop shop for all disciplines where they can go and perform operations like, launching applications. So you need to come in as an artist and launch Maya. You go to Hammer, it's there, you can launch it. You need some software to be installed on your machine because the editor requires it. Then Hammer's actually going to prompt you before launching the editor and ask you to install some software. You may be working with a development kit, so you need to actually set up an Xbox. Don't worry, Hammer's got you covered. It'll actually sort out your Xbox for you. And need the latest version of the game to actually test on your Xbox or your PC? No worries. You've got a few button clicks and Hammer will actually deploy this for you. So we wanted to remove a bunch of the barriers to entry for a lot of these more complex tasks. And the great things about running it through a tool like this meant that we could actually abstract a bunch of traditionally hard-coded things from things like Maya shells through to special editor plugins and dynamically load them through Hammer depending on what project you're actually running through, which is great. So Hammer is great, and people actually use it every day in the studio. However, as we started expanding on some of the features that tools like Hammer had, we actually started to hit something which we actually later regret and would have to find solutions for. The best way to illustrate this would probably go through a really simple standard workflow we do internally. So we take an artist, at his or her desk. They might come in the morning and say, hey, I've got to launch up our Hammer tool, which is the main central thing, and I need to go to Perforce using our special accelerated syncing tool called SmartSync and get the latest changes onto my PC. From there, said artist might be like, hey, I'm going to load up Maya and finish off the animation I was working on yesterday. And from there, they may say, cool, I finished my animation, I'm going to import it and preview it in our game so I can show my boss, and it's really, really awesome, I can submit that in. So we've actually made it really straightforward for our internal team to do this, but at what cost? So, all these super duper features, they definitely came at a price. All the effort to make these tools very easy to use meant we'd basically bound certain functionality and workflows to our internal site. Take Hammer, for example. We found that when we started digging into Hammer that, for example, our source control server, Perforce, was actually hard-coded into the source code, because who else would need a different Perforce server to work with it? We also found that those great features around installing software were actually hard-coded to like a network share internal to the studio. So if you needed to find that software, it was only valid inside the studio. We have great features such as if an artist or an engineer submit code, they go through a validation process on our build machines. But again, all of that infrastructure was hard-coded to our local site in Vancouver. And finally, things like the game deployment service that we have. It's really awesome that anyone, say, from QA can come in, press a button, get a build instantly on their kit. But again, only works here inside our own infrastructure. We had very similar problems with Unreal, which is the editor that we use. Unreal uses a very complex caching system, but we found that it was actually hard-coded in multiple places within our code base, which is unfortunate. And our editor can also take advantage of a distributed compute system. For this, we use Incredibuild, which is a third-party piece of software you can use, and this is also bound to our local setup. So how do we actually go about solving these kind of issues? So we originally explored certain ways of doing this, and our original idea was to actually expose a bunch of our infrastructure to our partners directly. But as you saw from Joe's slides, we have partners all around the globe, and problems such as bandwidth, latency, security, we couldn't really easily solve these. So we had to find a way to kind of decouple all of these things from our local site so we could get partners to have equivalent infrastructure on their own site. We knew the key way to solving this was actually from the root workflow that we all use every day, and that was Hammer. So with Hammer, we actually introduced something we call the Studio system, which has been super powerful. What this system allows is actually for us to abstract a bunch of all these hard-coded paths and dynamic environments custom for each of our partner sites. So then what it actually allows at that point is we actually check in a bunch of different configuration files, which actually allow our partners to go in and configure all of their local environment without us having to go in and actually help them. So this has actually solved a whole host of our distributed pipeline issues, and it's actually a system we still use today, and is very, very powerful. So at this point in the journey, we managed to get our partners access to our data, which is great. We distributed many of our tools and workflows to our partners as well. We're definitely well on our way of meeting our integrated development goals. Of course, there's also increased complexity, and now there's many more moving parts that could go wrong in new and exciting ways. For the next steps in our journey, Joe's going to talk about some of the support issues we initially faced and how we overcame them.
Thanks, Phil. So let's talk about syncing. Everyone has to sync. Syncs can take a long time, and nobody likes that. For example, syncing 100 gigs of data over nice fast 1 gig LAN connection could take something like 30 or 40 minutes to complete. That's a pretty long time. Now consider syncing that same data, that same 100 gigs from 10,000 kilometers away over a 100 megabit WAN link with a little bit of latency thrown in there. And now we could be looking at 4, 5, 6 hours to move that same 100 gigs. This is a situation that our partners quickly found themselves facing. Huge daily sync times from our server here in Vancouver to their local proxy servers. Sometimes these syncs could last all day. This was because, of course, their night is our day. And during our day, we would do things like submit 100 gigs of stuff into Perforce, changes that would need to be sent out to all the partner sites before they could even kind of get to work. Since the partners were just starting their syncs first thing in the morning, it might take most of the day to complete, and then they wouldn't even be able to perform any real work until later in that day. The next night, the same thing happens. The next day, they fall even further behind. Because we're trying to use an integrated development approach, we need everyone, including partners, to stay up to date with the latest code and tools all the time. Once you get a little too far out from the latest revision, you can't even perform basic tasks like opening the editor. And that's what we learned early on, and of course it seems obvious in retrospect. But for partners to be effective with integrated development, they need to stay up to date with changes every day and not fall behind. So to help tackle this, we built a couple of simple tools to try to bring some predictability and reliability to syncing at partner sites. The first tool is called the Super Pump, which can also be described as kind of a proxy primer. It works like this. Instead of waiting for someone to manually start a sync in the morning, we designed Super Pump to run all day long, constantly checking with our main server here in Vancouver, always trying to keep the local proxy server up to date with the latest changes. As it runs overnight, Super Pump keeps the local proxy up to date with the changes, and by the time staff arrive in the morning, the proxy is primed and ready to go. To complement Super Pump, we also introduced a system that allowed users to easily schedule syncs of their local Perforce client to happen early in the morning hours after the local proxy had already been primed. This way, staff workstations are already synced with latest changes from the night before in Vancouver. By using this combination of the Super Pump along with scheduled syncs, we were able to overcome many of our sync issues. These relatively simple solutions were able to provide our partners with more reliability and predictability in terms of making sure they had what they needed to do their work every day. We also have a very powerful material authoring solution which allows our teams to make incredible content and easily integrate it into our game. When we rolled this system out to our partners, they were amazed at what they could do with it, and so were we. But a challenge we faced was excessive shader compile times. It was taking hours to compile. This solution can be a serious resource hog. Opening a full Gears level in Unreal Editor could potentially take more than 8 hours as your machine tries desperately to compile tens of thousands of shaders in real time. At the Coalition, we solved this by using a shared compute solution built on a product called IncrediBuild. Our user machines can farm out the shader compilation work in real time to our IncrediBuild farm, which will enlist the help of dozens of other machines to perform the work. This means much faster opening and authoring of assets and elimination of excessive compile times. To further complement our shared compute farm, we use a derived data cache, or DDC. The DDC is a local file server that acts as a content cache for shaders, textures, and other assets. Once any machine generates assets, they're stored in the DDC and shared with other machines for use. So this was a problem for our partners. They couldn't really use this system or even perform some basic tasks like opening levels in the editor because of the lack of compute and cache available to them at their own sites. So to allow our partners to work at this greater level of integrated development, we deployed shared compute and DDC systems to partner sites. Let's take a look at what that looks like. So we have IncrediBuild, which runs a coordinator service that manages the jobs and the work being performed at the farm. Some sites have dedicated hardware for their farm. Other sites without dedicated hardware can be set up so that every user PC allocates a small number of CPU cores to the farm so that everyone can share them. Derived data caches were set up at each site and added to local Hammer Studio configs. We made further improvements to the DDC system, such as introducing compression to reduce file sizes and also replicating our internal DDC data from our site in Vancouver so partners could update their caches directly with our precompiled data, saving hours. By mimicking some of our own internal systems to external sites, we brought our partners more in line with our own internal expectations for performance. So let's take a look at how a typical partner site now looks at this point. So we've added shared compute as well as content caching. So we started pretty simple, just a proxy cache and some connectivity, and that got us partway there. Next, we deployed more tools, IncrediBuild and DDC. The partner infrastructure is starting to take on a little more complexity and now is more closely mirroring the systems we are using internally. So our journey continues, and we're building our external development stack. Now we have foundational connectivity established, we have distributed our tools, and we're supporting sites, fixing things, trying to make things better. But what was still missing was telemetry. We needed better ways of understanding what was going on at partner sites.
So as Joe mentioned, we had quite a few interesting support issues over our first few years. And actually it wasn't just our external teams facing these issues, it was actually our internal teams as well. As we were designing and building, deploying more and more tools and workflows, we came to realize we had no real way of knowing what our users were doing, and actually no idea of actually what issues they might be facing apart from the odd email or maybe a hallway chat with one of us. We knew we had a lot of different pieces of third-party software in the studio, many with custom add-ons or workflows from Visual Studio through to Houdini, WIs, many of the things that people here in this room will probably use as well. We also write and maintain a lot of our own internal tools, as well as things like our syncing tool we talked about earlier in Hammer, which brings in extra complexity. So how on earth are we supposed to get all this information from all these internal packages, let alone externally, and then troubleshoot problems and help our users? So we knew initially when we started doing this we'd have a bit of an uphill struggle, and so before we went down a path, we asked ourselves, what did we want from our ideal solution around telemetry? So we really wanted to unify all this telemetry from all these tools and workflows to make it easier for the team to understand what people were doing and basically correlate what people are doing between different applications, because we've got so many of them. We knew we owned a bunch of the data formats because we wrote some of the tools ourselves, so could we just standardize the telemetry and kind of jam all that into one system? Well, actually, we knew we used a lot of third-party tools as well, like Maya and Houdini, and how we're supposed to combine all that data together. We actually started looking at where the data came from and realized that there were so many data formats we didn't actually know where to start kind of jamming all this stuff together. And to complete our mystical unicorn, we also wanted a system which would allow us to see all this information, generate reports on it, and alerts so that we could actually action on the data that was coming in every day. So we actually spent a lot of time in investigations internally to find a solution that would actually fix a bunch of these problems for us. And in the end, our winner was something called Splunk. Some people in this room may have heard what Splunk is. Splunk is actually a third-party telemetry solution and analytics solution that you can go out and purchase. It's been such a boon for us inside the studio since we adopted it, because it brought so many winning features to the table, including it doesn't care about data formats, which was one of the big ones for us. So it didn't care about formatting, transforming, making all this thing and all this data into a unified format. It's simply you threw the data at Splunk, it could ingest it, and you could search on it, which was huge. It actually came with a bunch of third-party plugins as well, where there's a lot of information that we have from like machine data on machines, and we had no idea how to get that information into Splunk. It actually has these plugins. You install them, it throws them into Splunk, and you get all this information out, which is great. It has a hugely powerful inbuilt searching and visualization tool, but it's actually very, very simple to use, which is great as well. And finally, it came with a very easy reporting and alert solution. So it was easiest for us to set up, assign it to a bunch of our internal tools and workflows, and off we went. So I want to show how easy it is actually to get data into Splunk, and I'm not on commission here, so just bear with me. We said about adding a bunch of extra logging into our tooling, and this is how simple it was to actually get something through the pipeline. So here's a piece of code. That piece of code prints a log line. The log line basically is ingested by Splunk, and out pops a KPI, which actually allows us to do things like track every single user over time and what they're doing. So it was great that we had all this information coming in, which is awesome, but we actually started getting a little overwhelmed with the amount of data coming in from our tools and workflows initially. So what are we going to do with all this data, and how are we actually going to make it actionable? This is when we actually sat down and started looking at key performance indicators, or KPIs. This gave us a great language we could actually use to communicate with our dev team based on hard facts that were coming out of our tools and workflows that we could then action on. But when we started down this journey, we actually didn't know where to start. It wasn't an exact science, but we knew we had to start somewhere. So initially, when we started looking at some of these tools and workflows and KPIs, we did things like compare our engine internally to actually Epic's Unreal Engine to see what kind of performance and workflow differences we had and what we could track. Fortunately, like Joe said, we actually have a lot of different people at the studio who've worked on different engines who actually consulted them and asked them about what KPIs other engines use as well. One of the big things that we sat down with all the game team and actually talked about was like what's acceptable to them, that we want to actually make sure that we're actually tracking things which they care about. Is the editor fast enough for starting up, or is it taking too long for a shader to be compiled or an asset to be imported? And finally, one of the big things that we had for this was actually, because we could track all the data per user, we could actually start looking at worst case scenarios and help drive what we wanted to action on based on what people were reporting back to us. And finally, one of the biggest things that we do every single milestone is actually look at constant feedback from the dev team to help drive what new KPIs and help us prioritize what work we should be looking at based on actual facts rather than just hearsay, which has been a big win for us. Someone would generally come to us, they'll bring up an issue, we can help evaluate it, we can then look at adding telemetry to that if we haven't got some already. We can actually set a target which we say, we want to actually get to this point. We'll fix an issue, and then we can put alerts around those targets to make sure they never dip below where we want to set. So this is quite small. It's actually quite big here. It's quite small. So if you ever pass my desk, you'll see a whole host of monitors above my head with a variety of dashboards that look very much like this, with some of the core KPIs that we try to track inside the studio. And some of these I'll discuss a little bit later. And basically, we sit there as a team every day, looking at these numbers, seeing if they pass the threshold, waiting for alerts, and then seeing what we can action on. So it's all well and good that this actually works for our internal team, but then how are we going to actually action on issues that our partners were facing externally? They're thousands of kilometers away, and the data we're gathering is only from our local tools and workflows from here in Vancouver. So going back to the diagram that Joe just showed us before, we needed a solution that would get us all this awesome data from our partner sites back into Splunk so we could actually start actioning on some of the issues that our partners were facing. We originally explored using Perforce as a transfer system, but there was no real way that we could cleanly get that data back to us. So we introduced a new system, a new piece of infrastructure for each of our partner sites, which is called Signiant. Signiant is actually a fast transfer UDP solution which allows you to replicate data to and from partner sites. And with this system in place, we could then start gathering all the data that we needed. So we were able to piggyback off our existing Hammer Studio system, which then allowed us to redirect all of this great logging information, such as crashes, other data, from from the partner sites to our site. So basically, all we do is set up some Hammer configuration. That data goes through to a file share locally, which then Signiant replicates it to our site. We then have a very, very basic system which monitors a file share, and it pushes all that great information into Splunk. And hey presto, we have a telemetry pipeline for all of our partners. So setting up this solution has actually made a night and day difference to how we've operated on Gears. We could have, this is a good example we could have an individual user in China who hits a fatal crash during the day. We could then have another partner who's in the UK who has exactly the same crash that day. All that information can actually be sent back to Vancouver to us, and then within the same day, we can analyze that information, look at an issue, resolve it, push an issue out, and by the next time the partner actually wakes up and syncs in the morning, we might have that resolved, which we've never been able to do in the past, which has been super powerful. And it's something we never thought we could achieve with a system like this. This actually led us on to even greater things now, where we can actually track all of the same KPIs that we track internally for our dev team for each of our partners. And we actually give the ability for all of our external partners to see their own dashboards so they can help diagnose and debug their own issues locally before we might even wake up in the morning, which again has been super powerful for a bunch of our partners built on the same telemetry system. So I briefly touched on it before, Plus, it was a little small on the slides, but I want to talk about some of the key KPIs that were game changers for us with the support issues that we were seeing over time. So one thing that we have is a key issue that we faced, which Joe chatted about earlier, was actually that of sync times. This is actually directly tied to the state of our partners' proxy servers. We started tracking the state of the proxy servers through a key piece of telemetry, and so now we can actually alert and actually tell our partners if their proxy server is actually healthy and actually running, rather than waiting for a couple of days to realize they can't actually sync up, which has been huge for us. Another key indicator around partner health for us is actually things like the editor startup times. If it goes over a set threshold, it usually means there's something wrong and it can waste a huge amount of time for the partner sites. And we definitely need to jump on and resolve this ASAP, so we compare that all the time. Everyone's tools crashes, which, it happens. But this KPI is actually really, really good for us because we actually monitor how many times our editor crashes per editor session, which is a great indicator of partner health too. If it goes above any of our internal averages, it generally means something is wrong or misconfigured at a partner site. So generally we can jump on that and help them sort it out and kind of, resolve those issues. Another key indicator that we looked at, or KPI, was around load times. So it's given us really good insight into actually what our partners are working on and actually, where they might actually be finding some problems or issues with our workflows. So for example, if a partner loads up a frequently unload, a map which isn't frequently loaded, it can actually cause a massive amount of compute or shader compiles or texture compiles. So it's actually led us to actually unify and kind of cut down our workflows to provide them with things like Vista gyms and special lighting gyms they can work in, rather than having some of our partners load up massive levels, which could cause huge amounts of load time for them. And another thing that Joe touched on was also shader compiles. Because our engine is so heavily dependent on compute power, we also try to monitor how affected our partners are based on their local compute and their capacity. It has really helped us understand the impact we have when we make base shader changes, which impact all of our partners, and it's something we're definitely working on in the future to actually resolve this for a lot of our partners as well. So one thing I want to cover as well was actually things that we looked at. So initially, a lot of our KPIs, we didn't actually come up with them overnight. We actually went through a number of iterations trying to find perfect KPIs that actually work for both the internal studios and our external partners. And here's some ones that we found actually less actionable in the end. So we talked about the state of the Perforce proxy, but one thing that we've found quite difficult to actually action on is actual local individual users' sync times. You would think it'd be a good indicator, right? But while actually there's many things that are at play here, from like internal network speeds, partner internet speeds, many different things will actually make it super hard for us to action on. So we can tell our partners that they may be seeing slow sync times, which could be due to many different things, but it's actually become quite hard for us to actually action on this directly from the coalition. Another KPI that we use internally is number of hours actually spent in the editor. We thought, internally everyone uses the editor, so there'll be a good correlation between how we work and our partners work, but actually every partner is different, and some partners don't even use the editor, so it's actually not something we found super useful and actually can action on. Another KPI which we use very heavily internally is actually what we term play and editor startup times. So if I'm a designer, an artist, or an engineer, I may want to make a change, press a button in our editor, and actually see that on a session on my PC. We actually found that a lot of our partners don't actually have to use this workflow, so it's actually something we don't actually use a lot, and we can't really action on it for our partners. So all of these examples are, basically tells us every partner is different, and what you might think is relevant for everybody actually turns out not to be. So one key piece of feedback I would say is treat every partner differently, because in my opinion, you can gather as much telemetry as you want, but you never know which is actually going to prove useful and significant based on what setup the partner has. So we've just been over the key highlights of our development journey for the past 5 years, and the level of integration development we actually achieved today. However, as we all know in software development, there's always ways in which we can improve, so we're going to look at some of those ways that we're looking to do that. So, as you see, we've solved quite a few problems with external development issues, but there's actually a few more things that we want to do to get our goal of the perfect partner integrated development. There's some holy grail things that we're interested in looking at, and for the future, some of the ideas we have are looking at things like improving our partner support and our onboarding process for our partners, reducing the reliance on our engine compute needs right now, because that's one of our big goals, and also making better tools and workflow access for some of our new features that are actually adding to our tools and workflows on our engine. So as we've learned through onboarding and supporting our partners over the past few years, there's definitely more things that we can do to help them. We know in the future we probably want to deploy a larger set of tools and services to aid our partners in their development. We also know we're not always the fastest when it comes to setting up new partners, and this can be exacerbated by things like time zones, which don't always help. And we also know that the more partners that we add, the more support our team is going to face. And because every partner is slightly different, that's going to cause us some problems. So what can we do about this? So an idea that we've been thinking about at home is something called TC in a box, or the coalition in a box. The basic idea is that we could deploy a pre-configured box, which includes everything that our partners need, all the way from initially primed Perforce proxy and a super pump ready to go, a fully loaded DDC ready to use on day one with a caching service in place, our telemetry pipeline active and ready to go, and a fully integrated compute solution with enough horsepower to get our partners started. And from there, the idea would be that we would ship that over, we'd send it to our partners, they'd plug it into their network, and off they went. And the big thing that we could do here is actually then we would maintain and own the box. And we could monitor any issues via remote access and provide better level support and resolve things in real time for our partners. We feel this would basically reduce our spin-up time for partners. We unify a bunch of the setups we have right now, and actually then make this more of a turnkey operation, which is one of the things we're definitely looking at doing in the future. So another thing that we've talked about is that our engine is very, very heavily reliant on compute power. We have a lot of different operations that people can do which need a heavy amount of compute, from shader compiles internally. If one of our partners is actually doing code compiles, they can get things like 80% compile savings if they're using a compute farm. And light bakes as well also benefit from extra CPU horsepower. So all these processes are actually bound to local networks, which currently limit our partners based on local compute power they have. So we have a lot of compute horsepower in our studio, and we want to find ways of sharing this with our partners to make their lives better. So what if we could leverage something we already use today, and that's actually Microsoft data centers? We really want to look at exposing remote compute power inside something like Azure around the world, which are close to our partners, and they could take advantage of a centralized set of CPUs that they can scale out rather than scaling out their own internal infrastructure. We've actually done a lot of prototypes initially, and this actually looks super promising for our partners, and it's something that we definitely want to start rolling out when we've kind of finalized some of this work. And the final thing is we really want to improve on how we get our partners access to some of our more sophisticated tools. So as we previously discussed with our Hammer Studio solution, we've done a lot of work about making sure all of our tools and workflows can be distributed outside of our studio. However, we realize there's actually, as we make improvements and add more sophisticated workflows, we need to start doing more than just distributing executables through Perforce, which is mainly what we do right now. For features such as centralized data sources, concurrency, we definitely need to rely on one set of services or a single database, which doesn't really work well with our current integrated development model. So how can we solve these issues and still provide great tools and workflows to our partners? So one thing we're looking at is actually turning more towards a more traditional service model and start hosting things in the cloud. So internally, we actually have a services team that do this already for our game client, and we've got a lot to learn from them. We recently moved a few of our tools, actually for this project, into Azure, and we actually found it quite challenging to deal with some issues around latency and data volumes, which we definitely need to look at, but it's actually, it's a good first step. And it's definitely something we think is going to be a huge challenge for us over the next few years, but it'll make it so much easier to actually give our partners some of these more sophisticated tools and workflows. So let's finish up by looking at some key takeaways. And for that, I'll hand back to Joe.
Thanks, Phil. So if we look at what we learned as a studio during our external development journey, we could kind of boil it down to these lessons. To scale globally while keeping everyone integrated with your tools, you need a robust global connectivity solution so your partners can get to your data. You can't scale if you can't reliably deliver your content to your partners. You need to take steps to reduce the impact of distance. Long sync times and other data transfer problems can quickly derail production schedules, and you need to find ways to minimize the impact. Build abstraction layers into your tools and workflows so that configuration settings can be easily modified for different local environments. You need to be able to bring portability to the tools so they can be quickly deployed painlessly at partner sites. And be prepared to mirror your internal systems to partner sites to accelerate workflows like shared compute and content caching. Integrated development means many systems that are in place internally will also have to be deployed externally. And finally, add actionable telemetry to your workflows. This allows you to measure efficiency as well as pain points from your partners. And this data is invaluable to understanding the health and performance of your partners. So in conclusion, let me summarize what we talked about today. We talked about the challenges we faced when we first started this journey to work with external developers as a studio. We were a new studio, new franchise, new engine. And then we outlined our philosophies around our strategy of end-to-end integrated development. It ultimately saves time and money and results in a better product. And then we took you on a journey of the last 5 years of standing up this environment, including some of the problems we faced and how we overcame them. And we looked ahead at some of the challenges for our future selves and some of the ideas we have for making things better. And finally, we shared some of the key takeaways from our presentation today. So that's it for us. And thank you very much for listening to our story.